Today I'd like to just review some of the concepts of complex numbers with you. So I want to go ahead and pick a few to do on your FA together. So the first one that I'm going to do is the question number 3. Whenever you have the square root of a negative number, that is equal to I. So you need to take care of that first. So I'm going to say I square roots 32. So anytime you see the square root of a negative number, you're going to go ahead and take out an I because we know that the square root of negative 1 is equivalent to I. Then from there, I'm going to use a factor tree to simplify 32 if I can. So I've got 8 times 4, 4 times 2, 2 times 2, and 2 times 2. I'm going to circle pairs because this is a square root, and then underline anything that's left over. The pairs are going to go on the outside, so I've got 2 times 2 times I, and then inside we've got that leftover 2. If there was multiple things left over on the inside, I would multiply those together. So I have 4I square roots of 2. Okay, so that would be completely simplified. Now let's take a look at another one. Let's take a look at when we multiply two numbers together that have I. So 3 times negative 6 is negative 18. And then you're kind of treating the I like it's a variable. So like I times I would be I squared. Well, we know that I squared equals negative 1. So anytime that I see I squared, I can replace it with negative 1. So negative 18 times negative 1, this would be positive 18. So that would be completely simplified. All right. Now, when I add and subtract complex numbers, I just am going to add the parts that are alike, just like we normally would do. So I would say, I would distribute that. So I'd have 10 minus 7i minus 6 minus 9i. So I would have 10 minus 6, which would be 4, negative 7i minus 9i, which would be negative 16i. Done like that. Very, very simple and straightforward. Now, when I multiply two numbers together, and I'm going to actually do this one right here, okay, I'm actually going to double distribute, okay, just like I would normally. So I'm going to say 3 times 5, well, that's 15. Say 3 times negative 3i, that's negative 9i. 5i times 5 would be positive 25i, and then positive 5i minus, or times negative 3i would be negative 15i squared. I'm going to combine my like terms, so I've got 15, and then negative 9i plus 25i would be positive 16i. And then I know that I squared is negative 1, so I'm going to replace that with negative 1. Negative 15 times negative 1 would be a positive 15, so this would give me 30 plus 16i. And that would be my final answer that is in complex format. Okay? Now, just like when we have a radical in our denominator, we have to actually take that I and remove it from our denominator, just like if we had a radical. So the way that we do that is we multiply this thing by the complex, apparently I can't write, complex conjugate. There we go. And a complex conjugate is a complex number, so like if I had 1 plus I, it's the same two terms, but 1 and I, but with a different sign in the middle, okay? So this would be like 2 minus 3i. The complex conjugate would be 2 plus 3i. So for this problem up here, number 11, that's the one that we're going to look at, in order to get rid of this I in the denominator, I need to multiply by the complex conjugate, which is 3 minus 2i. Then I'm going to distribute that across the numerator and across the denominator. The reason that I can multiply by this is because it's equal to 1. 3 minus 2i divided by 3 minus 2i is just 1. So I'm not really changing the expression. So I've got 2 times 3 minus 2i in the numerator, and I've got 3 plus 2i times 3 minus 2i in the denominator. And let's go ahead and work that out. So 2 times 3 is 6. 2 times negative 2i is negative 4i. I've got 3 times 3, which is 9. 3 times negative 2i, which is negative 6i. 2i times 3, which is positive 6i. And then 2i times negative 2i, which is negative 4i squared. The nice thing about this is when I'm looking at this denominator, the 6i and the negative 6i are going to cancel each other out. So that's the term that would have had an I in it. And that's the reason why we use a conjugate, because when we use the conjugate, that middle term that is going to go ahead and cancel each other out. Then I know that I squared is equal to negative 1, so I've got 6 minus 4i divided by 9 minus 4 times negative 1. Well, I know that 9 plus 4, because negative 4 times negative 1 would be 13. And I'd have 6 minus 4i in my numerator. The last thing I need to do is turn that into complex format, which is a plus bi. So I have 6 over 13 minus 4 over 13i. And all I did was I did 6 divided by 13 and then negative 4i divided by 13. And that's how I got to this answer here, which is my simplified answer. The last one that I would like to go over is, well, first of all, number 13, I just want to talk through because it's really quick. When I look at this, in order to get rid of an I when there's only one term, so notice that we had 2 terms in the denominator in this last problem. Now I only have 1 term in the denominator, okay? So in order to do that, all I have to do is create an I squared. So I'm just going to multiply by I. That gives me 5i in the numerator, 2i squared in the denominator, which would be 5i over 2 times negative 1, because I squared is negative 1. So that would be negative 5 halves I. The I can be written out to the side like that, or it could be in the numerator as well. All right, last one, I promise. So I'm going to go ahead and take an I out first. So I've got I times the square root of 162 times I times the square root of 2. Then I'm going to go ahead and factor tree over here. I'm just going to go ahead and write 162 times 2, because I know that those would be 2 factors. And then I'm going to go from there. So 162, I'm going to say 2 and 81. Then I know that's 9 and 9, 3 and 3, 3 and 3. Circle your pairs. And it also looks like I have a pair of 2s. Okay, so that's really nice. We have I times I, which is I squared. So we're multiplying these 2 right here, this I and this I. And then I also know that I could bring out the 3, and then another 3, and a 2. So 3 times 3 is 9, times 2 is 18. I've got 18i squared. I know that that's going to be negative 18 because that's 18 times negative 1. Okay, so that would be how I would simplify those.